Sometimes you'll get an integral that has two functions multiplying each other. Separately, you might know how to integrate them, but together you aren't sure. This is where integration by parts comes into play. We know how to do u substitution, and integration by parts is very similar. Instead of picking a u, however, you need to pick a u and a dv. Then you're going to derive u and integrate dv, like this.
You might ask yourself, how do I know which functions to make u and which functions to make dv? For this, use limit. Limit tells you which function to make u. The function that comes earliest in the limit sequence is what you're going to make u. So, for example, if you have an inverse trig function and an exponential function, you would then make the inverse trig function u. The exponential function would then become your dv.
After you've derived u and integrated dv, here's the formula for integration by part. A simple way to remember this is multiply diagonally from u to v, then put a minus sign, and finally integrate horizontally from v to du.
Let's do an example. Here we have the integral of x times cosine of x. Looking at limit, you have x, which is a polynomial, and cosine x, which is a trig function. P comes before t, so make x your u and cosine x your dv. The derivative of x, of course, is 1, and the integral of cosine x is going to be sine x. Now, plug all of this into the formula. U times v is x times sine x. Then, put the subtraction sign. Now, put the integral of du times b. That's sine x times 1, which is just sine x. Then, the last thing you have to do is integrate sine x, which gives you negative cosine x. But remember that there's a subtraction sign in front of it, so really you have positive x. The final answer is x times sine x plus cosine x plus c.